By now, most of my loyal viewers, will be familiar with my 1911 Detroit heater, which was manufactured by the American Electrical Heater Co. Now, this is a fairly common radiant electric heater design that dates back to the early 20th century. This one was made in approximately 1911. Could be later, could be earlier. And it uses a fairly common, for the time period, radiant heat bulb. Now, these lamps are colloquially known as sausage bulbs. So if you're looking for this type of a bulb, that is the search term, unfortunately, that you're going to want to use. And that's because of the size and shape of the bulb is obviously not dissimilar to that of a typical sausage of the time period. Summer sausage and maybe not kielbasa, but I think kielbasa bulbs would be narrower and longer. I don't know. Anyway, these bulbs are very hard to find. So you've got to make the best of what you've got. So if you still have a functioning or multiple functioning bulbs and the base is coming loose, this video is for you. Now, this video, or the methods used in this video, will work with any incandescent bulb from any time period. I don't believe much has changed in the manufacturing of bulbs over the past 120 years or so. They still make them in pretty much the same way they did back then. But obviously the antique bulbs have some value to them, especially these. These bulbs, when you can find them, can range anywhere from $20 to even $50 a bulb. So that's when it becomes cost effective to start looking at repair options. Obviously, if the bulb has lost vacuum for any reason, or if the filament is burned, it is now a decorative piece and nothing else. But I am fortunate enough to have 3 original American Electrical Heater Co. bulbs in my heater. Now, these have never been replaced, and they all work. The problem was, again, the bases were cemented on with an asbestos cement that over time has cracked and crumbled. And 2 of these bulbs had to be repaired, and that is what this video is all about. This one in the middle did not require the repair, but these 2 on the outer ends, they were coming apart in a bad way. So this video is long. It isn't terribly entertaining. It is meant to be a kind of a show and tell of how I fixed the problem with my bulbs, and I'm hoping it can help some of you antique collectors and bulb aficionados solve your own problems. Now, the materials that I used, one of the materials I used is a little bit hard to come by. You can order this online, but you won't find it at your local Walmart. You will not find it at Home Depot. You will not find it at any auto parts store. This is a putty that I used. It's called 907 GF Resbond. It runs about $30, including shipping within the continental U.S. I paid, what was it? It was like 20 bucks for the tube and $10 for shipping. So it was about $30 for this right here, that alone. That's a 4-ounce tube, and real quick, it has a very high heat rating, 2300 degrees Fahrenheit. We're going to be talking more about this later in the video, but this is what you're going to want to use to re-cement the bases to your bulbs. You're also going to need some painter's tape. You're going to want some desoldering braid, some leaded solder. You're also going to want a soldering iron, because we need to desolder and resolder the leads coming out of the bulb globe. So you're going to need those things. You're going to need a small flat blade screwdriver. This is going to help you shape the putty and remove some of the old material. You're also going to want to wear a face mask. You're going to want to take proper precautions for friable asbestos. Unfortunately, back in 1911, asbestos was used in everything from tablecloths to children's clothing. It was used in cement, it was used in adhesives. Anything they could put asbestos into Hell, they probably used it in bread. They used to use asbestos to decorate Christmas trees. You would just dust this asbestos, these snowflakes, all over your trees. And that's why so many people are dying from mesothelioma today. So take precautions. Use appropriate. I'm not going to tell you what to use, but you can do your own research on that. You will be working with friable asbestos. Just forewarning you. You're also going to want some sandpaper. This is 220 grit sandpaper. I like that stuff. You're going to want to get some brass cleaner. I use either Brasso, or you're going to want to get some, what did I use? Some no-name brand that I don't really buy frequently, but any brass cleaner should do. I did not need steel wool, but it's good to have some quadruple zero steel wool on hand. Anything else? I think that pretty much covers it. The problem that we have here is that these bases are loose. They're actually falling off the envelope because the ceramic compound that they used has completely failed. It's cracked, it's separated from the envelope of the bulb, and it's separating from the base. Now what that does is, if you're removing or installing one of these bulbs, is it puts a lot of tension and torture on the bulb leads themselves. Now that's a problem because once the leads break off of the base of the bulb from fatigue failure, which will happen, the bulb is essentially no damn good. So I want to fix these bulbs before it becomes a bigger problem. I've taken the worst one. Now this one is so bad that enough of the material has fallen out of the base so that the bulb no longer sits straight. It actually kind of curves a little bit, curves over a little bit. Let's see here. If I go this way with it. Alright. So I'm going to desolder the outer leg. And we're going to try it. Now this lamp has not been apart since about 1911. So pre-Titanic. Looks like that cement is in better shape than I thought. Okay. But like I said, it is cracking. I mean, look at that shit. It's just everywhere. It's just falling right out. Alright. It's coming. Coming. Don't break those leads off. That would really suck. You can't see any of this. Got it. Okay. Wow. Take a look at this. How often do you get to see the base of a 105-year-old light bulb? Look at that. You see where the leads come right out? There's the center, and there's the outer. So there's a little bit of room for these to kind of flex a little bit before they start breaking and going to hell. So that's good. And the cement-filled bulb base in all its glory. So this repair definitely has to happen. I mean, it definitely does now. The question is, what is the best approach? I mean, the cement just completely cracked and it's falling apart. which is very sad. I'm going to take the rest of the solder off of that, clean it up a little bit. Okay, so now we have something to work with. Let's kill the iron. And I'm going to have to pick up some of that sealant. Okay, let's talk sealants. Now, we have to reattach that base somehow using a material that has a few properties. For example, it must be able to resist a constant exposure to temperatures at or above 500 degrees. It must be dielectric, meaning it cannot conduct electricity, meaning it cannot contain iron powder. It must also have structural shear resistance or structural integrity at temperature under stress. It must be flowable, yet hardened when it dries. It also cannot have certain chemical properties that could degrade metals. We're looking for liquid unicorn. And I contacted a gentleman who works for the biggest lamp manufacturer on planet Earth. It's a small world, and I happen to know someone who is, I believe, in the engineering department for this company. And I said exactly what I was looking for. I'm trying to resecure a lamp base to a bulb. A bulb that you guys may have manufactured over 106 years ago. And he said, I will look into it. So he contacted me 2 days later with a correspondence that he received from another engineer within the network of plants. And so there was real thought and real engineering that went involved into this decision. It wasn't something I picked up at Home Depot. Although I admit, I tried. I went to Home Depot and I found nothing that would do the job. Not one thing they had would do this. So I got a response that contained two possible solutions. Number one was a material that cost $200 a gallon, 1 gallon minimum, and I was having none of that. So the second solution was much more reasonable. It cost me $30 for a 4-ounce tube, and if you saw the beginning of this video, you know what I'm talking about. Here it is, the solution. This is 907 GF putty by Resbond. It costs $29 including shipping. It is designed for constant exposure up to 2350 degrees Fahrenheit. Yeah, this is the unicorn we're looking for. It is designed to work on a variety of materials, including steel, iron, lead, ceramics, metals, glass, no plastics, and it won't bond to your hands. It's delicious like that. The other thing is it has no noxious fumes. In fact, I can't detect any real noticeable odor at all. It's also fairly safe to use, has a health rating of 1, fire rating of 0, and a radiation rating of 0 as well. Which means, for those of you who have never worked with industrial chemicals and solvents, it is fairly safe. It is rated a 1 for mild skin irritation, possible skin irritation. It is not flammable, even in its wet form. It is not, obviously, not in its dry form. It is not radioactive. So this is the solution we've all been looking for. This is it. You can get it online. I think I bought it directly from Cotronics. But if you Google 907 GF putty, you will find what you're looking for. You will not find this at Walmart. You will not find this at Best Buy. Don't know why you would. You won't find this in your local auto repair place, but it probably should be available to the retail. Actually, no. It actually says right on the tube it's for industrial use only. So this is not considered safe for consumers for some reason. Don't know why. But that's it. That's what we used. And again, it's not something I just picked out of my brain. I contacted actual engineers because this is a one-shot. I have one chance to do this, one shot to fix it. If I screw it up, the bulb is ruined forever. A lot of pressure, so I wanted to do it right. One of the other recommendations was actually from a couple of gentlemen who work in antique radio and television restoration. I think Bob Anderson had been using this stuff for vacuum tubes, which don't get nearly as hot as a radiant heat lamp, but they use a material called flowable silicone. It's sold in the auto parts stores as a windshield sealant, and believe me, I've used it. It's good stuff. But it's only rated for 400, and that may not be constant exposure. That could also be acute exposure. So, not what we're looking for. But 907 GF putty, it actually cures to a consistency similar to what we pulled out. So, for what it's worth, this is your solution. All right, on with the show. Okay, in full disclosure, this is actually the second lamp. The first one, I made a few mistakes, and I've learned from those mistakes. So I figured we might as well just reshoot this scene. You'll notice I've made an impromptu lamp stand out of this mug. And by the way, if you're from Maryland, thumbs up. I bought this mug next to the Waffle House in Hagerstown, Maryland. Visiting family. Okay, and I ate at that Waffle House, and it was alright. First time I ever had Waffle House. Word of caution. I just took this one apart, just like we did with the first bulb. And I took a close look at the cement that they used way back in 1911. And here it is. Pure white as snow. I don't know for a fact, but I am going to speculate that what I'm holding is some of nature's finest asbestos. So what we're doing differently here is we're going to be applying some painter's tape to the lamp. Now this is to protect the bulb's etched surface from the that cement-like substance that we're going to be using. Okay, so we've got our lamp base protected, our bulb envelope protected from any excess cement, and we're going to go and do the same thing for the base itself. This is actually kind of a critical step. You really want to do this. I just spent a great deal of time cleaning off excess cement on the other base that I just did, and boy was it no fun. Boy was it no fun. So we're gonna do this now. Make it nice and clean. This is gonna make assembly a little bit easier for us in the long run, and it will protect that nice brass patina from having to be cleaned later on. We're going to be cleaning the base with a brass cleaner anyway, but I don't want to go through what I just went through. Let me just put it that way. So we've got our base all nice and protected. I'm going to take our 907 GF putty by Resbond, or that is the product name. We want to make sure not to get the Resbond onto this terminal here, or on this lead. We also want to make sure while we're here, want to make double sure that there's nothing down in that barrel. This is your last and final chance to do this. You'll never get another opportunity to clean that out. You don't want any solder. You don't want any putty. You want nothing in there. It should be completely empty. Okay, so we're going to take our 907 Res Bond. We're going to apply it into the base, like so. Doing this backwards. You just squeeze it in there. You can use a lot. It's okay. It's going to spread around. That's fine. Okay, so you want it to look kind of like that. Then we're going to apply some of that Res Bond into the flared end of the envelope. This is where the center of the envelope meets the outer part of the envelope, where the mother meets the child, or the two spouses meet. Alright, you don't want to get this, or too much of this, on your what's it there? You don't want to get it on your leads. You want to do your best to keep those free and clear of Res Bond. Okay. Then we're going to very carefully drop the base onto the envelope. And we're going to have to guide the wire through. I'm going to do this over here in the light so I can see what the hell I'm doing. One final check to make sure the leads are not crossed. You will not get another opportunity ever to do this. Get it? Good. This is your one shot. This is kind of tricky. It takes a little bit of patience, a little bit of dexterity. It helps to make sure that the wire is nice and straight. Once you get that base on there, you want to give it a good twist back and forth to really seat it in. Okay, at this point we're going to use our fingers to remove any excess sealant. I suggest wearing gloves. We're going to take another look at our filament lead wire. Make sure that it pokes out. And you can even hold the lamp up to, or the bulb up to a lamp once you get all that stuff removed. But we're going to try to eyeball this thing to make sure that that base is on straight at this point in time. But I think it's safe to start cleaning up some of that excess. But I can't stress this enough. You want to make sure that those leads do not cross. You have about half an hour to an hour at the most to make sure you've got this right. You will not get another opportunity to do so. Once this stuff cures, it is permanent. It will not come off. All the king's horses and all the king's men cannot help you. They'll just laugh at you. So we're going to take our outer wrap off here. making sure that we don't have any of this stuff on our hands. We're going to leave whatever on the base for now, that's okay. But we're going to double check to make sure that the base is on straight by rotating the bulb with clean hands. The great thing about this sealant is it comes right off your fingers if you just rub it. It's pretty cool. It does not bond to your skin. It won't bond to your desk apparently. And it's easy to clean up, I mean even when it's cured. Now, I still got a little bit of excess on the on that bulb base, but that's okay. I'm going to clean it right off with my finger. You can use a wet finger, that might help. I'm going to just get the rest of that shit off there. Okay. I'm going to rotate the bulb gently, zoom out a little bit here, and we're going to just kind of rotate it and just make sure that it's really on there nice and straight. Appears to be. Yeah, it appears to be. And we're going to store the bulb in the upright position. We're not going to bother to solder any leads yet. This could be our last thing. Our last step, if you will. But yeah, it's pretty much all set now. There we go. Once that cures, we give it about a day, 24 hours, then we can start soldering away. I'm going to take this screwdriver and kind of just scrape away some of the excess, especially, again, around that filament lead there on the outside, the outer filament lead. This one was cut kind of short. The other one I had a little more wire to work with. This one I don't have anything really. So emphasis on this is a one-shot deal, guys. You screw it up, it's done. You can work with it for up to about half an hour before the stuff really begins to cure. And we can use our fingernails to scrape off any excess like that. So that's what we're doing. Get it right down in there. Make sure it's down there. This stuff will cure pretty hard. So we're going to take this time, take this opportunity to make sure we got it right. I know I've been harping on that point. Yeah, the other one I did all my learning on that other bulb, and but think of this, don't think of this as something that, think of this as an investment in your antique. Keeping the original bulbs intact, whether they work or not, believe it or not, is better than not having them at all. And breaking a bulb would be really devastating, and having one of these bulbs fail would be even more heartbreaking. So this one looks pretty damn good. The other one, I could have done better, but this is what I got. I learned a little bit. This is on right. It's on straight. I'm going to take another look. I'm going to take a flashlight, and I'm going to point it down into the lamp using that little side window that they conveniently left us, and make sure that those leads are in there straight. They're not crossed over. They're not twisted. Everything looks good. I can even see the bond around the envelope of the bulb, and it looks pretty good. So I think we're all set here. I see a nice good coating. Good. If the chemical bond doesn't get it, the mechanical bond will. This is going to be a long-lasting repair. Alright, so we have to solder this center lead by folding it down into this groove. And we're then going to apply a liberal amount of solder into that to make it nice and smooth. We want to make sure that when we do that, we don't want the lamp vertical, because what will happen is some solder will actually draw down the lead and potentially drip into the mantle of the bulb, where the two leads go into the sealed envelope. The more challenging repair will be right here. This is that secondary connection. That has to be soldered to the edge of the base. They didn't leave us with a lot of wire to work with, but I think we can do it. Alright, before I do that, I'm going to take some of my 220 and I'm going to sand the base, clean up any oxidization where we're going to be soldering it, just enough to clean it up a little bit. You want to solder to clean metal and nothing else. Take a look at that. Nice. This is the one I was worried about right here on the edge, but it came out okay. Let's take a look at that. That beauty. Alright, let's take this sucker downstairs and we're going to polish the brass. Then we're going to test it out along with the other bulb and see what happens. Okay, so we're going to be polishing the brass base with Wright's brass polish. Why Wright's? Because it was cheaper than Brasso. And it works pretty well. I mean, I think it works just as well as Brasso. Probably contains many of the same chemicals too. One of the great things about brass polish is that you don't really have to work it hard. You just let it do its, let the chemicals do the work for you. And just get it, apply it liberally to the base, and it'll wash off everything. It'll clean off everything else. Just kind of let it sit there for a bit. Let it do its job. It's already doing its job. You see that? Look at that. Doing a great job. Okay, alright, let's take a quick look at our repaired bulb again. Take a look at that beautiful base, nice and strong, good and polished. Just thread it in. Look at how straight this bulb is now. It was kind of crooked before. Who wants to see it go? I know I do. Alright, we're going to start it off in low. You see the light flicker above me? Medium. And finally high. Now I'm going to take this stuff away. We're going to just kind of let it glow for a little while. You can actually see the filament. Look at that. Watch. Watch it blow. Ah, that would suck. That would totally suck.